Hello students, today we shall learn to place root 7 on a number line, okay? To place root 7 on a number line, first we should know Pythagoras theorem. H square equal to p square plus b square. We all know this relation, isn't it? For any right angle triangle, hypotenuse square is always equal to perpendicular square plus base square, isn't it? So to place root 7 on a number line, hypotenuse must be equal to root 7. We must assume hypotenuse equal to root 7, okay? To place root 7 on a number line, hypotenuse must be equal to root 7. To place root 5 on a number line, hypotenuse must be equal to root 5. To place root 3 on a number line, hypotenuse must be equal to root 3. What I mean to say is, the number which we are going to place on a number line must be assumed as hypotenuse, okay? And we should keep in mind that perpendicular is equal to 1 for every case, okay? Perpendicular must be equal to 1. Main task is to find base, isn't it? So base is unknown to us. Let's find base from this relation. H square equal to p square plus b square, okay? Now what we do is, we keep this h square in the left hand side, h square. Let us bring this plus p square to the left hand side, becomes minus p square equal to b square is left in the right hand side, b square. So we got b square equal to h square minus p square. This is Pythagoras theorem, isn't it? B square equal to h square minus p square, okay? From this relation we are going to find base, or b square equal to, so what is h? H is root 7. We write root 7 here. So we have a square, let's put the square, minus sign we write here. So p is 1, so we write 1 square. Or b equal to root 7 square. Root 7 square means root 7 into root 7. So root 7 into root 7 equal to 7, isn't it? Root x into root x equal to x, okay? Root 3 into root 3 equal to 3. So root 7 square means root 7 into root 7, that is 7, minus 1 square is 1 into 1, that is 1. So we take this square to the right hand side, becomes root under. So we got b equal to this root, we write here root 7 minus 1 is 6. So we got base as root 6, isn't it? We got base as root 6. When hypotenuse is root 7 and perpendicular is 1, we got base as root 6, okay? But we cannot place root 6 on a number line. So what we do is, we assume this base as new hypotenuse, okay? And we are going to continue this until we get base as proper number. Proper number means the number without root, okay? Now we assume this is second case, okay? We assume hypotenuse, new hypotenuse as root 6. This base is assumed as hypotenuse, okay? This base is taken as hypotenuse for the second case. Base is root 6. And we know that perpendicular is always equal to 1. So let's find the base again. Base is unknown to us, okay? From the same relation, b square equal to h square minus p square, okay? So b square equal to h square minus p square, isn't it? So what is h? H is root 6, h square, h is root 6, h square minus p square, isn't it? So what is p? P is 1, so 1 square. Or b equal to root 6 square is 6, root 6 into root 6 is 6, minus 1 square is 1, 1 into 1 is 1. So we take this square to the right hand side, becomes root under, okay? So we got b equal to root under, so we write root here, 6 minus 1 is 5, isn't it? So we got another base, and another base is also number under the root, isn't it? So b equal to root 5. Now we cannot place root 5 also in the number line. So what we do is, we continue again until we get base as a root free number, okay? So this base is again assumed as hypotenuse. In the third case, hypotenuse equal to root 5, okay? The new hypotenuse is root 5. This base is taken as hypotenuse. Perpendicular is always 1. Okay, now let us find the base again. So from the same relation, b square equal to h square minus p square. Okay, so we're going to find base. So b square equal to, so what is h square? H is root 5 square minus p square. What is p? P equal to 1, so 1 square. Or b square equal to root 5 square means 5. Root 5 into root 5 is 5. This minus we write here. 1 square is 1. 1 into 1 is 1. So this square we take to the right hand side becomes root under. Or we got base equal to 5 minus 4 is 5 minus 1 is 4. Root under 4. This root, we have root 5 minus 4 is 5 minus 1 is 4. Therefore base equal to root 4 means 2 2s are 4, isn't it? 2. So we got base as a root free number, that is 2. So base should be equal to 2. Okay, now let's place root 7 on a number line. Okay, let me erase this. Okay, so this is 0, this is 1, this is 2, this is 3, and so on. To the left of 0 we have negative numbers, and to the right of 0 we have positive numbers. This is 1, this is 2. Okay, so this is 3. When the base is 2, okay, first we place this. When the base is 2 and perpendicular is 1, when the base is 2 and perpendicular is 1, we got hypotenuse as root 5, isn't it? When the base is 2, perpendicular is 1, we got hypotenuse as root 5. So what we do is we take base as 2 unit from 0, 1, 2, and we draw perpendicular as 1 unit. So this is 1. Okay, 1 unit, equal length of this 1. This is 1. Now so suppose this is O. Okay, this is A and this is B. Now we join OB. OB are joined. So OA is 2 unit, base is 2. AB is 1 unit, this is perpendicular 1 unit. And in this case, when base is 2 and perpendicular is 1, hypotenuse is root 5. When base is 2, perpendicular is 1, hypotenuse is root 5, isn't it? So when base is 2, perpendicular 1, hypotenuse is root 5. Now what we do is, again we draw a perpendicular to OB, this line. Okay, so we draw another perpendicular line. Perpendicular means 90 degree. Okay, we have 90 degree here, we have 90 degree here. Another line OBC is drawn. This is C. BC is drawn. BC is perpendicular to OB. BC is perpendicular to OB. Okay, now we join O and C. O and C are joined. Okay, you can see another right angle triangle OBC, isn't it? In this right angle triangle OBC, base is OB, OB is root 5, and perpendicular is BC, BC is taken as 1. Okay, now let's see. When base is root 5, and perpendicular is 1, hypotenuse is root 6, isn't it? When base is root 5, perpendicular 1, hypotenuse is root 6. So when base is root 5, perpendicular is 1, hypotenuse is root 6. This is hypotenuse, root 6. Okay, let me write clearly. This is hypotenuse, root 6. Root 6. Okay, now again we draw another perpendicular line, perpendicular to OC. Okay, we draw another perpendicular 1 unit long. Okay, this to this is 1 unit. So CD, suppose this is D, CD is 1 unit, perpendicular is 1 unit. Okay, CD is 1 unit. Now we join O and D again. O and D are joined. So when OC is root 6, you can see OC is we see another right angle triangle OCD, isn't it? OCD. This is another right angle triangle. OC is the base. OC is root 6. CD is perpendicular. CD is 1 unit. Okay. So when base is root 6, and perpendicular is 1, when base is root 6 and perpendicular is 1, hypotenuse is root 7, isn't it? So when base OC is root 6 and perpendicular is CD, that is 1, then hypotenuse OD is root 7. Okay, so OD is root 7. So we got root 7 here. Length of OD is root 7, isn't it? Length of line segment OD is root 7. So what we do now is we place the needle of the compass here and the tip of the pencil here. Okay, we take the needle of the compass here and tip of the pencil here and just draw an arc. Arc is drawn. Okay, we place the needle of the compass here, tip of the pencil here, and we draw an arc. So this point from O to D and O to, let's suppose this as point P. Okay, O to D and O to P are equal radius of this circle, isn't it? So OP is root 7 because OD is root 7. OD is root 7 means OP also must be equal to root 7. So this is how we place root 7 on a number line. Okay, I hope you got this. If you understood the concept, then please don't hesitate to subscribe the channel and share with your friends. Thank you so much and stay tuned. I'll upload more of the contents like this in the future. Thank you.